I like the fact that we're constantly learning. We're learning new things all the time, and we're contributing to the knowledge in the world about the living world and also the kind of synthetic world. But I also really like training the next generation of scientists. The overall theme of research in the group is that of biological self-assembly. There are many examples of biological self-assembly, and we look at protein folding, and we also look at peptide aggregation. So that's peptides self-assembling into fibrillar structures and other states. Some of our research you would class as being very pure, in that we are doing it without an application in mind. We were the first group worldwide to start studying how knotted proteins fold. So this was a type of protein structure that was completely unexpected. The other work that we do is much more applied, and that's looking at peptide self-assembly and looking at therapeutic peptide self-assembly. So this has got two impacts. First of all, the pharmaceutical industry sometimes wants to suppress aggregation, which can be a big problem in the development and formulation of peptide-based drugs. But there's also another aspect, which is sometimes that the self-assembly itself is very advantageous, and we can use the self-assembly of peptides into fibrillar forms or microcrystalline forms, and those forms can actually be very useful and applied as slow-release biological agents. Currently we have 4 projects. We are beginning to look at how some knotted proteins which do not occur naturally in nature, but which have been designed by a protein design group in Seattle, how they fold, and that's quite a new and an exciting project. We're looking at the self-assembly of a peptide called GLP-1. So this is glucagon-like peptide number 1, and it and its analogues are widely used as treatment for diabetes. We have another project which is on, again, it's on potentially a therapeutic peptide. This is not a naturally occurring peptide, but a peptide that has been developed by medicinal chemists for use as a cancer treatment for prostate cancer. And then the last project is on therapeutic antibodies. So we use a number of different biophysical techniques to study the stability and dynamics and structure of therapeutic antibodies, and in particular on antibodies going through the clinic, which are being used to create antibody drug conjugates. So this is kind of the next generation of therapeutic antibodies. I have an older brother who went to university. He went to the University of Nottingham to study architecture, but neither of my parents went to university. And in fact, my dad didn't even complete school. He left school aged 14. He didn't even have a leaving certificate, and he worked on a farm for many years. He ended up without a degree at all, being on the board of directors of a division of ICI. I don't think I found arriving in Cambridge as a culture shock, and that's because I had been to the University of Oxford as an undergraduate, but I do remember arriving there from school and it being a bit of a culture shock, and I remember thinking everybody else was really clever and much cleverer than I was. By the time I got to Cambridge, I was kind of very familiar with the Oxbridge Oxbridge environment and college system.